Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, we are doing something a little bit different with this training session. This is pre-recorded, so I won't be able to answer your questions live. Now, if you do have any questions, if you're on Zoom, unfortunately, I won't be able to answer them. But if you watch this on YouTube or Facebook, you can always leave a comment underneath the video, and I'll get back to those, within a week or so after this originally airs. So, with that, my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 8 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple of years as a diagnostic sales rep with Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. And before that, it was 8 years at Subaru. So over time, I guess, became that diagnostic guy in the shop. Always ended up with the intermittent problems, the drivability problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out any of those weird head scratcher type problems that would come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic this week is chassis electronics. There is way more electronics in your chassis nowadays on a modern vehicle than there certainly ever used to be. And we're going to focus on these three main areas here. So we're going to focus on the steering systems, because we do have electronic power steering nowadays. We're going to talk a little bit about air suspension with a real world case study, and also electronic suspension or magnetic suspension. You may have heard of it called that as well. So we'll dive into each of those three types of systems. So first off is going to be steering systems. So steering systems, as far as electronics go, they've become a lot more advanced than they have been in the past. We have steering angle sensors. We've had those for a bit with ABS and such, but now they're integrated within the rack oftentimes. And also with that comes the torque effort sensor as well. And then we also have, as I said, the electric steering rack, which has the electric motor in there as well. So a lot of electronics involved, just even in your simple steering wheel that used to just be just a direct connection right to the rack from the wheel there. So first off, let's talk about the steering angle sensor, right? So that's been around for a while. Oftentimes it was up right behind the steering wheel. So it translates rotational motion into electronic signals. So it has like a little electromagnetic encoder in there that allows the vehicle to understand where is this steering wheel in 360-degree rotation. So I'm 25 degrees to the left, or I'm 80 degrees to the right. It allows the computer to know which way that steering wheel is turned. It's keyed to the steering shaft in order to, so it kind of only goes one way. So we can't have it in upside down or anything like that. As I said, often located near the steering wheel. Many times it's attached to the clock spring, so that'd be used for like the airbag. And it must be calibrated after repairs. So if I do an alignment, if I do any chassis or suspension work, if I do replace a tie rod, any of those things, we would need to recalibrate the steering wheel so the computer doesn't miscalculate the direction of the vehicle when it needs to be calculated. So under like a braking or an emergency maneuver or something like that, it needs to know where is that steering wheel and what is that steering wheel doing. So this is the way we've done it for a while with that steering angle sensor. But nowadays, on a modern rack and pinion here, we have the tie rods still, right? We have our inner and outer tie rods and the boots, and it still has a rack in there, and we still have an input shaft. But on that input shaft, we have a torque sensor in there now. So if we think about, the vehicle needs to understand how much effort is also being put into the steering wheel. And if I have this electronic assist, I don't have a hydraulic pressure anymore. If it's just an electric motor, and we'll see how that drives here in a second. But if I'm only using the electric motor assist and I'm not using a hydraulic assist, the resistance will be different than what we're used to. So with this torque sensor on the input shaft, oftentimes there's a torsion bar in there as well to give us that little bit of feedback and resistance in the system as well. So here's a closer look at that torque and angle sensor. So they're all kind of combined into one now. And oftentimes when you relearn it, you're going to be doing relearning the torque and the steering angle at the same time. So you see we got a connector here. It's just this is my input shaft cover. Input shaft comes in through here in the top. And then there is my torque effort sensor, as well as the steering angle sensor is integrated with that as well, some GM. And then we have the electric assist motor. As I said, we're not used to the way it used to be, or we're not using the system the way it used to be with the power steering pump. And we have valves inside the input shaft that would push it one way or the other and help us out with the steering while still also having the pinion. Nowadays, it runs off this electric motor, which is controlled by a control module. And that control module turns the motor whichever way the wheel needs to go. And then you see we have this belt, it's a heavy duty belt inside the system. And then it turns this, kind of looks like a ball bearing. So it's like a ball and screw design, they call it. So the shaft for the inner tie rod, that main rack shaft there, that has spherical twists in it. And so when it turns, when this gear, the spherical gear here, it's got spheres inside. So it's like a ball bearing, like I said. As it rides in those grooves, it'll push that shaft in and out. And that's how it's able to translate the circular motion of the belt into a linear motion side to side with the rack. So as we turn one way, the motor turns one way, we turn the other way, the motor turns the other way. Right. So, and allows that shaft to go back and forth just like we would on a manual rack or with a hydraulically assisted power steering rack. It's the same type of principle. We're just using an electric motor and sensors and a control module to do it instead of having all of these hydraulics with the pumps and all that. So overall, decreases the amount of parasitic loss on the engine as far as power is concerned. Plus the other advantage of this, if we think about ADAS on a vehicle nowadays, so if I have a lane departure situation and my vehicle has active lane departure where it'll pull it back into the lane. So say I drift over a little bit with this electric power steering, it can override the steering input from the driver and just steer the vehicle back to where it needs to go. So that allows that type of system to work, having this electronic power steering or electric power steering versus having the old school pump and hydraulics and all that. So that's our steering systems. Now let's look at suspension. So we have two main types of suspension that have electronics involved anyways. So we still have our old school springs and struts and shocks. But with the air suspension allows us to change the ride height and change the way that the vehicle moves. Here's just an example on a 2019 Jeep Grand Cherokee, and here are all the parts that are involved in this. So first off, there's an air tank, because air suspension, we need to be able to fill and empty those air springs. We have the control module. It's going to be sitting there underneath the seat there. We have an air strut, or a shock and air spring assembly is what they call it. We have the compressor and the valve block. So this has our air compressor in there and also our valves, so it can send the air to whatever corner of the vehicle we need. We have the front height sensor right here, which kind of sits on the chassis, and it is a just kind of an arm that lets the vehicle know how high or how low it is sitting. And of course, we have all the air lines underneath the vehicle. In the rear, instead of being like a more of a strut assembly, it's more of just like an individual air spring in the back, just kind of mounted on the chassis there. And then we have the rear height sensor, which works in the same fashion as the front height sensor. It just has an arm on it, and it moves depending on the height of the vehicle where it is. So here's just an example of it all put together in the front here with this Jeep. And you see how we have the air springs and shock assembly. So it's essentially a strut if you think about it that way. And then we still have our sway bars, and we still have our upper control arms and our knuckles and our lower control arms and all that stuff that we're used to. Really, all this air suspension is doing is, instead of a metal spring, we are using air as a spring. So it can give you a little bit better ride. We can change the ride height of the vehicle up or down by a few millimeters in either direction. In this, it has a couple up and a couple down, depending on the situation. So we could have like a sport mode, a sand mode, a snow mode. It'll change the height of the vehicle using that air to change the modes and change the ride height of the vehicle. How high off the ground is it riding? So let's say, for example, if we're looking at this front suspension here, let's say I needed to replace one of these control arms for some reason or another, whatever reason it might be. Maybe it got in a wreck and something got bent, or maybe I don't know, one reason or another, we need to replace that control arm. All right, so let's say we do need to replace it. So how would we go about this? We need to do a few things in order to replace this, and we need to use the scan tool to be able to do it. So we'll look at step number one on removal on the suspension arms and links. So this would be, say, your upper control arm here. If equipped with air suspension, with a scan tool using the routines under the ASCM, so that's the air suspension control module, perform the following. Disable the air suspension system, because when we put it in the air, we don't want the air suspension system actuating. And then we also need to run the spring deflate to reservoir routine on the air suspension spring on the side where the upper control arm is to be removed. So we need to bleed the air out and put it in the tank so we can have it for later. So we pull up our scan tool and we can scroll down a little bit till we get to our steering and chassis area, and we have our air suspension control module right there. So we'll pop in, and then that is listed under miscellaneous functions with this. So as we can see, there's 2, 4, 6, 8, 10, 12, 13 different functions available in here on this air suspension system on the 2019 Jeep. Now, we're going to have to do a couple different things in order to complete this entire repair. So first off, as they said, we need to disable the control. So that's this one right here is disable level control, enter plant mode. So the routine will perform the following functions. Disable the level control for the current ignition cycle. Place the air suspension control module into plant mode. Note, to enable the level control again, cycle the ignition and it'll enable it. To exit plant mode, please run exit plant mode routine. So that's another functional test we have. Or drive the vehicle over 8 miles an hour, 13 kilometers per hour. And then all it has to do is we just hit continue and it says level control is successfully disabled. It's like throwing a switch inside the computer. The air suspension control module will remain in plant mode until the exit plant mode routine is run or the vehicle is driven over 8 miles an hour. So apparently when they're building these at the plant and they're in plant mode, they don't go over 8 miles an hour, I guess, according to that anyways. Next thing we had to do is it said after we disabled it, we had to deflate the spring to the reservoir. So we'll go in there, deflate the reservoir. Performing miscellaneous functions may cause a certain code to be set. In order to clear this, go to exit plant mode and it'll clear that code. So while we're doing this test, if it's in plant mode, it may set a code. Exiting plant mode clears that code. Then it says this routine will deflate a selected spring back to the reservoir. So we hit continue. And it says, please note the air suspension control module will deflate the air springs to a predefined pressure set point, and therefore some residual pressure will be left inside the spring. So we're not going to have an entirely flat, empty spring, but it's going to be close. To measure residual pressure after venting, please run the component air mass pressure ride height readings routine. So that is another functional test we can do to measure the pressure. To completely deflate the air springs, it may be necessary to loosen the airline fitting. So you crack the line, let some of the rest of the air out. So let's say in this example, we want to do some suspension work on the right front. Maybe that's the right front control arm. So we'd go to the right front air spring. And then we have a short time deflate and then a complete deflate. So I would want to completely deflate this because I may need to do some extra work in there and not have that spring fully inflated. So we could go and do a complete deflate. It'll deflate back to the tank. Then we go through, we do our work, we do our repair, and then we need to do an after repair function. So if we come down here under our repair after we're done, step 18 here says if equipped with air suspension with a scan tool using the routines under the air suspension control module, perform the following. Fill spring from reservoir, complete fill on the air suspension spring on the side where the upper control arm was installed. So that's the right side on this case. Run the air mass calculation routine on the air suspension system. If necessary, add to the system or deflate to atmosphere using those routines. So we have those functional tests in there as well. Then repeat the air mass calculation routine again until the system responds with air mass OK, which would be between 188 and 216 bar liters. Enable the air suspension system. So that's the exit plant mode. If equipped with air suspension, perform the ASCM verification test as well. So we'll come in here and we'll do fill spring from reservoir. And that says this routine will fill the selected spring from the reservoir. We'll hit continue. Right front air spring is the one we want. And then we'll do a complete fill. Remember how it said to do a complete fill. And then we would need to do, we would do the air mass pressure ride height readings. We're not going to go through that in this particular section, but we would want to do that first. And then we'll go into exit plant mode and it'll exit the plant mode. And then at that point, we're complete in our repair. Next one's kind of an interesting topic. This is electronic suspension. So this uses electricity to help change how stiff our ride is. So here's just this is a screenshot from GM's website because this was created kind of in conjunction with GM. And you can see we got all these molecules in there. So we'll talk about what that means. So Electronic suspension, other way you could call it, is magnetic ride control. So this was originally developed by Delphi in conjunction with GM. It was kind of a secret project, so to speak. So a lot of other places in the industry weren't really aware that this was even being developed or going on, but it debuted in Cadillac in 2003. So there was a Cadillac model that it debuted in that. And then shortly thereafter, a little bit later in the year, debuted on the Corvette back then. So it's used on a lot of GM vehicles, Cadillacs, Corvette, like I said, on pickup trucks nowadays as well, the Silverados. It's used on those. It's also used in, they licensed the technology out, Delphi did. So Audi has it, Ferrari has it, Ford uses it in the Mustang Shelby 350. A few Land Rover models have it, and then Lamborghini Aventador also uses it as well. So this is kind of a cool little technology. I thought this was kind of neat, and it definitely fits in perfectly with the topic we're talking about here. So it uses electronics, and it has this fluid inside. So to replace the oil that's inside my shocks and struts, we have an oil that is intermixed with iron. So they call it a ferro fluid. So ferrous metal, iron. So iron is magnetic too, right? So it works with a magnet. So what it does is it passes current through this fluid through a valve. The more current that flows through, the stiffer the fluid gets. So it arranges those molecules along the magnetic field lines. So the more current that flows through, the stronger that field is, because we know if we throw a current through a magnet or an electromagnet, it'll generate a magnetic field. So when we're doing this, it'll stiffen up, and depending on how much it stiffens up will depend on how stiff the suspension reacts, because it has to go through a valve. All right, so here's just another view of that. So we have these tubes, the channels that go through it. We have pressure over here, and we have pressure coming out over here. And we have the piston that would go up and down inside the shock. So we have the magnetic ride fluid. In a non-magnetic state, we see all the molecules are kind of jumbled up. They're just kind of floating around doing their own thing. Once it gets in a magnetic state, by putting current into these opposing electromagnets, you see this direction of magnetic field here. We have these electromagnetic coils on either side, and it will have this magnetic field in there. As it does so, as I said, it arranges those in a chain along the lines of the magnetic field. The greater the current, the greater the magnetic field. The larger the magnetic field makes that ferrofluid stiffer. This can react in the tiniest fraction of a second. One story I saw, or one good analogy that I saw into how fast this can react. If I'm driving down the highway and I get over a bridge and I hit one of the expansion joints on the bridge, the system will react fast enough to change the stiffness of the suspension before the front tire's contact patch finishes touching that expansion joint. How big is an expansion joint? It's not that big. So as the car hits it, the second that tire hits it, it'll sense it, and then it will adjust accordingly. Now, if we think about how fast that adjusted for the front, the back has the entire car length to adjust. So it's able to adjust, and you really get a much nicer ride, a much smoother ride for that. So it's great for handling. If you want some sport maneuvers, you can change it and adjust it by changing the amount of amperage that flows through it. So I thought that's kind of cool how they can do that. And you can use the magnets and the magnetic field and all that in order to change the suspension on the fly in milliseconds in order to change that. So I thought that was kind of a cool little technology that's out there now. And like I said, it's been out there for, well, it's getting close to 20 years. 2003, we're pretty close, 18 years or so. That technology has been out there and around. So when you replace these things, there may be some tests that need to get done. There may be some resets or relearns, depending on any of these systems that we talked about nowadays or today during this session. There are many different resets, relearns that we might need to do. So let's talk about a few of those right now. Go live on the tool. Okay. So here's our scan tool, and I'm just going to pull some vehicles out of the vehicle history here. So the first one I want to do is that Cadillac, right? So a Cadillac here with the it has the electronic suspension, this Cadillac. So we were just talking about that, so that's perfect for this. So we'll go in here into our scanner. And we'll let it initialize. Here we go, demo mode. There we go. So as we see on this car, there are 60 different resets, relearns, recalibrations available on this car. But if I go down to the control module here, we have the suspension control module. We have a power steering control module too, because it also has electronic power steering assist. But we'll go to suspension control module here. And there's a few things we can do in here. Not a ton, but we can read the data and see different ride heights and things. We'll go into functional tests. And you can see we have the different damper actuators we can read in here. So let's say we wanted to do the right front damper actuator. And really what this is going to be is it's going to be an on-off type situation. So it makes it active or inactive. And then you can see the voltages change accordingly. And then the amperage draw change accordingly as well. So if I go to active, if I was hooked up to the car, you'd be able to see these change. You see the amperage go up. You can see the different voltages, how they're affected as it's being active or inactive. And really, so you can turn it on and to exit the program to turn it off. If I wanted to, I suppose I could, as long as I can get around the wiring, I could use a low amp probe there and make sure that the amperage is in fact getting to that particular suspension piece. All right, so that is what we can do on that Cadillac. Let's look at some steering. So I'm going to load this Acadia here. 2018 GMC Acadia. So this has the electronic power steering rack. This has the torque sensor. This has the integrated steering angle sensor as well. So let's go into service resets and relearns and see what we can find in here. So this is, if you don't know what this is, service resets and relearns. This is available on all Fast Track Intelligent Diagnostics equipped tools, so Zeus, Triton, and Apollo, and it's also available on the Veris Edge. Now, you do have to have an active software subscription on the Intelligent Diagnostic tools, and then on the Veris Edge, you need to have current software to access it. But what it is a quick link to get us to more our resets and our relearns instead of having to go through the module and trying to find them on the screen. So if I go to steering and chassis, it says replace or adjust the steering wheel position sensor. So we'll go into functional resets and calibrations, and you see we have a steering wheel angle sensor centering, and we have a steering wheel angle sensor learn. So there's a centering process, and then there's a relearn process. I have to do the relearn after I do any sort of work, any sort of steering work there, any sort of like an alignment, or if I do a tie rod, or anything really with the steering that affects the geometry of the steering wheel. If I pull the steering wheel up, all of those, we need to do a relearn. So I'm going to go into learn here. It'll load up for me. Okay, so easy enough. It says turn the ignition on, align the front wheel straight, and center the steering wheel. So once that's all done, we'll hit continue. And it comes in here, and then we just hit a learn function. It gives us some data that applies to it as well. And then all we do is hit learn, and then procedure is complete. So really what we're doing is learning in. Once we know those wheels are straight, it's just going to say to the computer, here's 0. Here's where we need to learn where 0 is. All right, so that's that. If I want more information, though, as well, if you have Shopkey and you have one of these Windows-based tools, we could go into repair information as well and get more information on the steering system on this truck as well. So I'm going to show you that. So it logs in, logs the vehicle in for me, and then it'll do a search for the steering. So steering wheel position sensor will go in there. And then we can see we have different guided component tests and wiring diagrams and removal and replacement. How about after repair information? All right, so after repair information is going to be what we just did, right? So it's centering and stop learning. So that was our centering. We did that. We need to do that centering job anytime we do the steering angle sensor replacement, steering gear replacement, power steering assist motor replacement, steering column replacement, steering linkage, inner tie rod or outer tie rod. And then it walks us through how we would center the wheel before we do the reset. Line the front wheels, and then from the center position, slowly 90 degrees to the left, slowly 90 degrees to the right, and then back to the center. And then that will center the wheels, and then we just hit reset on the scan tool. Now, another interesting thing is if we go under parts, because remember how it said that steering wheel position sensor, right? So if I go into electronic steering on this, and I look up that torque position sensor, which was also part of the with the steering angle sensor, this is the whole unit. So the whole power steering assist motor assembly, the rack, you got to buy the rack, and it's $530 in order to buy that rack. So it's all kind of included in there with that assembly. So I just thought that was kind of interesting too. It can't even buy it separate regardless. So you do need to do that anytime you do. If you need to replace the sensor, you got to replace the rack. So that's kind of fun. All right, let's go into another suspension item here. Is a Ford F-150. My simulator. So this Ford F-150, we actually use this. If you saw our software update as well on this latest software update 21.4, we added this vehicle dynamics module, which is going to control the suspension system on this vehicle. So there's a couple, there's a test that we can do in here that'll help us out when it comes to doing any work. Go in here. And under functional tests, we have special functions, and it is the ride height calibration. So do you remember on that Jeep, we had those ride height sensors in there. So what this will do is it needs to recalibrate the ride height of the vehicle. So what we need to do is we'll walk through, and the procedure is used to calibrate each of the 4 suspension height position sensors to the vehicle suspension position. Before performing this procedure, please make sure the following operations are completed. There must be no suspension height sensor fault codes. The vehicle must be on level ground and no occupants in the vehicle. So we want to make sure it's at curb weight and it's sitting at the curb ride height. The height sensor calibration routine should not be performed with the vehicle raised off the ground or immediately after lowering the vehicle, as the suspension will not be in a neutral position. To neutralize the suspension, back the vehicle approximately 50 feet and back into the stall. So back out 50 feet, go back in, then continue with the calibration procedure. Refer to the appropriate workshop manual for further details. So I want to make sure it is level, flat, could do it on a rack, make it nice and level. And then we'll continue. We also have to tell it how much fuel's in the tank. So let's just say it's 3/4 full. It's going to perform the function. It's basically going to measure and see what are the outputs of each of these 4 corners on the vehicle. Then it'll go through a 10-second countdown. It'll give you the calibration status on the screen. Once they're all calibrated, we're done. All right, so it says turn the ignition off. Turn it back to run, hit continue. And then it's going to tell, it should tell me functions complete. There we go, functions complete on that. All right, so that is ride height calibration on the air suspension on an F-150. I'll give you one more. This one this one gets talked about an awful lot here. So this is on a 2012 Mercedes CL, and that has air suspension. So there's a suspension control module in here, and there's a really interesting name for one of these tests in here. So in this case, I'm going to go into service resets and relearns because it's nice and easy to get in there. And then if I go all the way down here to my steering and chassis, we have the reset suspension height. So if I do any work on the air suspension, really on any of the vehicles, I think you've noticed a running theme here. Once I'm done with any repairs, I need to do a calibration. But in this one, there's a couple different ways to do it. So I'm a simulator, so I got to run through a couple choices here real quick. And there is a category in here. There's a test in here that I get asked about a lot. And it's called, the official name apparently is cyclic alternating actuation of all suspension circuits in circular motion. Friendly name of that is called rodeo mode. So what it does, if you ever seen a video, or if you've ever seen this done in real life of a Mercedes, they have this mode in order to bleed the system. It basically makes the car rotate on its 4 corners of a suspension in sequence. So it's like it's at a rodeo, right? Like a bucking bronco. So it would go through here and it actuates them on all 4 corners. I don't think you're going to get to see too much with the scan tool because all the action's outside the car. But do be aware, if you need to do this function, risk of injury caused by moving parts that can pinch, crush, or in extreme cases, even sever limbs. You want to keep your hands away from the car when it's doing this because it's automatically moving it around. No parts of the body or limb should be within the operating range of the mechanism when moving components. Close the trunk lid, engine hood, and all the doors, because otherwise we're going to have the hood slamming and things like that. And then you're going to say, by continuing, I herewith confirm that I have read the safety notes, and make sure the engine's idling. So hit OK. And then it's going to walk through. And then all I have to do is hit start. And then it's going to start rotating the vehicle. So it's going to give me a 60-second countdown here. And then I can watch the different pressures and such and voltages go through. Now, in this case, we're not obviously not hooked up to a car. So you wouldn't, this is all going to be dummy data. It's not actual live data, but you would be able to watch that as the car is cycling through that mode. If you ever needed to stop at any time, you can simply hit stop and it'll stop. All right, so that is chassis electrical. A lot of interesting stuff out there when it comes to chassis electronics, to be sure. So hopefully we picked up a few tips on how to better walk through that and better understand a little bit how it works and what we might need to do after the fact if we do have a repair that we need to be done. You always do need to do some sort of calibration on the vehicle. So let's talk about what we're going to talk about next week. So our all new classes continue next week, and it will be live, and it's going to be on HVAC electronics. So we're going to talk things like blend mode actuators and the different ways that we're using with the blower motors, with the different resistors or modules that we have now. It's not usually a resistor anymore, and the different functions and calibrations and things we need to do in order to work on modern HVAC systems. I'm concentrating mainly on the in-cabin stuff, not really AC pressures or anything like that. But a lot of things like the actuators and blend doors and automatic AC and things like that. So same time, same place, 6 and 9 Eastern. If you want to join us on Zoom, go to snapon.com/OT. You can sign yourself up. Or the 6 Eastern class goes to YouTube. So it's going to be live streamed on YouTube. So youtube.com/snapon-diagnostics. If you're on YouTube, please make sure you subscribe to our channel and hit that little notification bell right next to the subscribe button. So you will get a notification next time we go live or post any new content there. The 9 p.m. Eastern class goes live to Facebook. So if you prefer to watch on Facebook, we have that available too. It's going to be at facebook.com/SnapOnJason, all one word, no dash in Snap-on. So SnapOnJason is my username there. You can give me a follow and you'll know anytime I go live there as well. If you have any interest in watching any of our other previous live stream topics, you can go and check out our YouTube channel as well. There is a playlist for all of our live training videos. So everything from intro to ADOS, data bus testing, module setup, a bunch of the component testing classes we did over the summer here, as well as our newer classes that we just started a couple weeks ago. So this is being one of them. So this will be actually episode number 30. So with that, as I said, this is pre-recorded this week, so we don't have a way to really answer your questions live. But if you do have a question that you come up with, feel free, if you're watching on YouTube, comment on the YouTube video. If you're watching on Facebook, comment on the Facebook video. And I will be back live next week. So with that, I also want to make sure I mention before I go my buddy Al. So Al McCaskey also does live video training. He is scan tool based. So on Mondays, he does Apollo. Wednesdays, he does Zeus. Thursday, he does Triton. So this is very comprehensive class. Goes all the way from let's set up your Wi-Fi, all the way through let's set up your free Snap-on Cloud account so you can share files with your customers, all the way through let's go through code to completion, complete workflow process on Fast Track Intelligent Diagnostics on the tool. And it will show you, if you've never experienced this before, how it can help you save a ton of time when it comes to diagnosing a car. So that's about an hour worth of material. So the Zeus and the Triton, he does that same first hour just on their respective tools. Then on those 2 nights, after a 5-minute break, he'll go through the guided component test, the lab scope, all the different scope and meter functions inside the tool with real world examples. That's about another hour. So these are very thorough classes. Al is very knowledgeable. He's been with us for over 30 years. So it's definitely worth your time to check it out. You may pick up a few tips and tricks, even if you've been using the tool for a while. So it's worth the price of admission for sure. It's 5 and 8 p.m. Eastern time, same time as my classes on Tuesday, 5 and 8 Central, 6 and 9 Eastern. All right, so if you want to go there, go to snapon.com/OT to sign up for one of Al's many classes. And with that, thank you for taking out the time out of your busy week to spend some time with me. Hopefully we learned a little bit more about our different suspension and steering and chassis electronics that we talked about today. Enjoy the rest of your week. Enjoy your weekend. Hopefully we'll see you next week for HVAC electronics. Enjoy your evening and take care.